Chapter 10, Section 11, type of bond, types of bond. So this section, we're going to study how atoms or elements combine, make compounds. What kind of force hold different elements, atoms together? That's electrical force. Electrical force. But we have special name. Uh, and there are basically two types. One we call covalent bond. Another one we call ionic bond. Uh, okay, we need to know the differences between the covalent and ionic bonds. Okay, so covalent bond is one or more electron pairs, the pairs of electrons shared by two atoms. For example, hydrogen. Hydrogen has only one electron. Okay, in first energy shell. So now first shell can hold up to two. So need one more to close. Now when hydrogen meet hydrogen, they both want to close, right? So this atom want electron from this one, and this atom want same thing, want this electron. So now as a result, these two electrons gonna stay between. Like two atoms share one pair of electrons, two electrons stay right here. So now they hold each other because electrons negative charge, right? So positive and positive between you have one pair negative charge. So they hold each other by sharing electron pairs. So we call covalent bond. Oxygen and nitrogen work same way. So now let's see what is ionic. That's ions, right? So ion, ions. Ions means atom lose electron or catch electron. Okay, so ionic bond is one or more electrons shift. The key word is shift or transfer from one atom to another. Example, see the table salt. This is the chlorine and sodium. Okay, so chlorine has 17 electrons. To state the first one, 8. Then the third one has 7 electrons. Okay, we call alkali elements very active because just need one more to close. And sodium at the same time has 11. First two closed, the third energy shell only has 1. Okay, so this alkali metal want to lose 1 electron. So when these two combine, what happens is this electron go to that one, chlorine. So then after they have 2 ions, the chlorine become negative because 17 positive charge, but 18 negative charge catch one from sodium. Same time, sodium become positive because 11 positive charge, only 10 negative. So one positive ion, one negative ion. So they attract each other, stick together. Okay, so remember the two words. Sharing electron pairs. That's covalent bond. And shifting electrons. Electrons go from one to another. We call ionic bond. Okay, so when atoms combine chemically, usually you have certain energy in and out, so they combine together. Okay, so we're going to discuss a little more detail. Okay, so now the hydrogen going to share one pair because need one to close. So here's a sample. Sometimes we use this H, two hydrogen atoms and one pair between. Now oxygen going to share 2 pair. Why? Because oxygen need 2 to close all the shell. So oxygen totally has 8. The the first energy shell has 2, second one has 6. Need 2 more, make 8. So what happens? They're going to share 2 pair. Nitrogen for similar reason going to share 3 pair. So they're going to share electron pair or pairs called covalent compound. Okay, section 13, we are not going to study, just tell you. Okay, 1 plus means offer 1 electrons. That's the alkalis. Okay, then the second column, second group, share 2 pair. So the 2 plus. Aluminum belongs to the third. So we're going to share 3 electrons. Or transfer 3 electrons. Some elements have 2 possibilities. Sometimes offer 1, sometimes 2. Okay, then the negative sign here means catch electrons. Catch electrons. Okay, so now we discuss a little more about the ionic bond, ionic compounds. Okay, so now in ionic compounds, electrons have to pair off. Means how many electrons transfer depends on different situation. We already discussed sodium and chlorine. Sodium want to give 1 to close, chlorine need 1 to close. So 1 sodium combined with 1 chlorine atom. See, 1 to 1. Okay, so now the calcium and oxygen combined. Okay, so calcium want to give 2 electrons, plus 2. Oxygen need 2. So you're going to have okay 2 electrons to transfer. Okay, so that's what happens. So now when sodium and sulfur combine, well, sodium want to give 1, but sulfur need 2. So what happens? You're going to have 2 sodium atoms combined with 1 sulfur. So 2 sodium give 2, 1 sulfur need 2. So 2 electron transferred. So this formula, okay, why is this way? Because they have to match electrons. Okay, so now see when aluminum and oxygen combine, we call aluminum oxide. So see 2 and 3. Why? Because aluminum want to give 3. We just follow this table here. See aluminum want to give 3. And oxygen need 2. Okay, so now what's going to happen is every 2 aluminum atoms combine with 3 oxygen atoms. So 2 each give 3, so totally 6 electrons. And 3 oxygen each need 2, also 6. Okay, so that's what happens. So they have to match the number of electrons. We're not going to study 15. So now go 17. We're going to study very basic concept of chemical equation. Okay. A chemical equation is shorthand way to chemical reaction before and after what happens. So the atom on each side of the equation must be balanced, must keep the same number. For example, we know this carbon, oxygen. Oxygen always 2 stick together like 1 molecules. So when carbon and oxygen combine, give you carbon dioxide. Okay, so this is a perfect match, right? It's balanced. Before you have 1 carbon, 2 oxygen, after the same. Sometimes when we study the chemical reaction, we need to balance the equation. In order to correctly represent a chemical reaction, the number of atoms of each kind must be the same for both sides of the equation. Okay, so let's see. Decomposition of water. the water molecules break up, give you what? Hydrogen and oxygen. Water give you hydrogen and oxygen. Okay, so before we have water molecules, two hydrogen, one oxygen. After this one molecule of hydrogen, two atoms, and also this one uh, molecule of oxygen, two atoms. And you can see it's not balanced because before and after you have two and two hydrogen, but before only one oxygen, after two oxygen atoms. We call unbalanced. So we want to balance it. Okay, so now we how we can balance after we have two oxygen before only one. So how about we times two? Remember when you times two, the whole molecules times two. So that means you have four hydrogen atoms and two oxygen, right? So now oxygen is okay. You have two before and two after. But hydrogen now you have four hydrogen atoms, only two after. So we need to go one more step. So now we times two again. Okay, so now it's balanced. Before you have two water molecules, totally that's four hydrogen and two oxygen. And the after, okay, you have two times two give you four hydrogen and two oxygen. So before after, they're balanced. So what this tells us, that means so every two water molecules break up decomposition will give you two hydrogen molecules plus one oxygen. And if we do this lab, we can prove it. So you have water, you add electricity, then decomposition happens. So then produce gases are going to stay inside because it's closed. This end is closed. One side give you the oxygen, one side give you hydrogen. You're going to find hydrogen always two times more the volume compared to oxygen. Okay, so now we discuss another example. We use propane, that's natural gases. Propane, the molecule has 3 carbon plus 8 hydrogen. Okay, so when this propane, the gas is burning, okay, what happens? Going to produce the carbon dioxide and water vapor. But you had to add some oxygen, right? Propane always burning in air because oxygen. So these molecules plus oxygen give you carbon dioxide and water vapor. Okay, so now let's see. Okay, so the chemical equation. So we start left side. We have propane molecules and plus oxygen. Then after give you carbon dioxide plus this water. Okay, so now the first you check the number. First thing, the carbon is not balanced, right? 3 before and 1 after. And also not oxygen. Okay, so we need to balance this. So now we have carbon, we have hydrogen, oxygen. Which one we should balance first? Generally, it's easier balance hydrogen and oxygen the last. Well, the reason because they appear at different place, so it's easier balance other first. By the way, I will not ask you balance equation. I only ask you if this equation is balanced or unbalanced. Okay, you just need to count the number. Tell me if it's balanced uh, or unbalanced. Okay, now this is not balanced, right? So as the rule, we are going to balance carbon first. Before you have three, after only one, there's no carbon there. So first thing is okay times three. So let's balance one first. So three carbon and three carbon. So carbon is okay. So next one, how about hydrogen? So before you have eight hydrogen atoms. And this one has no, this one has no, and this one has only two. Before you have eight, after two. So okay, so it's times four here. So times four. So now you see 4 times 2 gives you 8. So before and after, now you have same carbon, 3 each side, and 8 hydrogen. This 8, and 2 times 4 gives 8. Okay. So now, how about the last one, oxygen? So before we have 2, and after, let's be careful. This one has 2 times 3 give you 6, and 4. 6 plus 4 give you 10. So 10 oxygen after. Before only 2. Well, so times 5. Okay, so now everything's balanced. Okay, so you're going to have 3 carbon each side, 8 hydrogen, 2 times 4, and 10. 2 times 5 gives you 10. Then, well, we did this already. 6 plus 4 oxygen atom give you 10. So it's balanced. So this balanced. So now what it tell us? Tell us every propane molecules need 5 oxygen molecules together. Then we'll give you 3 carbon dioxide plus 4 water molecules. Now the chemical equation balancing is very important. For example, in chemical industry, you're going to produce a lot, tons of chemical products, right? So you have to know how much of this and that give you how much of what, right? Like this example, every propane molecules, natural gas molecules, you need 5 times of oxygen. Take a lot of oxygen. Then give you 3 carbon dioxide and 4 water molecules. Okay, here I'll give you some for practice. So that's a 4 equation. Okay, so don't look answer first, and you see which one is the balanced or unbalanced. Like first one you can check, okay, at least you find luminant 2 after 1 before, right? So it's the unbalanced. This one 2 mercury and 2 oxygen. Okay, then 2 of each. This is balanced. Okay, so if I ask you chemical equation, I will not ask you balance it, but I will ask you which one is balanced or which one's unbalanced. Okay, so now we can start the last part. We can start the important unit. You need to remember the name and definition. And this unit we call a mole. Mole, M-O-L-E. So now why we study this? Because when we counting the atoms, well, you know the number is huge. So the atoms too small to count. If I have like one small beaker of the water, Well, how many molecules inside? Trillions of trillions. So now, um, the chemists must counting atoms. So they have to calculate the chemical reaction, how much give you how much what. So now, since you cannot counting atoms directly, uh, well, it's much easier measure the mass. So you only need a balance. Uh, so measuring mass is more straightforward. So then we need to find the connection between the mass and the number. So if you know the connection, we just measure the mass, find the weight, then you know the number of atoms in the sample, right? Okay, so you just need to know the weight of the water in the beaker, and you know how many molecules inside. Okay, so now let's remember we studied atomic mass unit. That is U. Uh, 1 U as mass unit. Okay, equals 1.66 times 10 to the power negative 24 gram. So you use kilogram to be negative 27. Okay, so this is the mass of one single nucleon. Proton or neutron. They're almost same mass, this much. Okay, first thing we study hydrogen. Uh, so now, if you have 1 gram of hydrogen, do you know how many molecules inside? Or how many atoms inside? Okay, so we know each hydrogen has only 1 proton, obviously 1 nucleon. Uh, and 1 nucleon, this much weight. Okay, and totally we have 1 gram, right? So 1 gram, that's the total number of the sample, 1 gram of hydrogen divided by the mass of one single atoms. Okay, going to give you a big number. You can try, and this number is very famous number, 6.02, 10 to the power 23. Okay, so this huge number, 6 times 10 to the power 23. Okay, 23 zeros. Okay, so 1 gram of hydrogen has so many atoms. Okay, so now second example, let's check how about helium. Well, the helium has 4 nucleons, 2 proton plus 2 neutron. So we can imagine, okay, so the mass must be 4 times of the hydrogen. So now if you use a 4 gram divided by 1 nuclear, that's totally 4 nucleons. Of course, give you the same number. Okay, and this number 6.02 10 to the power 23 we call Avogadro constant or Avogadro number, Na. Well, you don't need to remember this number. It's a huge number. Number of Avogadro. 6.022 keep by more digits, 10 to the power 23. Okay, and this number we call 1 mole. MOLE. So mole is the unit of substances. 1 mole of any substances contains same number. Okay, so we just need to know 1 mole of something, and we know how many atoms or molecules inside, right? Let's say 1 mole of the hydrogen and helium, same number, of course different weight. Okay, so that's let me read again. Mole is the unit of substances. 1 mole of any substances contains same number of molecules, same number. 1 mole of hydrogen, oxygen, anything. mercury. Okay, they have same number. Okay, so here's some example. So we take hydrogen, helium, uh, carbon, and oxygen. These are the molecules. Okay, they have different weight. 1 mole of hydrogen, 1 mole of helium, carbon, and oxygen molecules. The weight is different, the number is same. See? Okay, same number. So 1 mole of any substances contains same number of molecules. So this conclusion we should remember. So that's how scientists counting molecules. They cannot count one by one. They count use mole. 1 mole, 2 mole, or 0.1 mole, 0.01 mole. Okay, so because you know 1 mole of anything is same number. 6.02 times 10 to the power 23. So the conclusion tells us 1 mole of any substances okay, have same number of the molecules, but different number of the mass, different masses. Same number, different mass. Same number, different mass. That's mole. Okay, so this is the end of chapter 10. Thank you.